Energy and chemical and physical change. When we have chemical and physical changes, there are frequently energy changes involved with those. And what we observe is that systems with high potential energy have a tendency to change in a way that lowers their potential energy. So if we go back to the piano hanging out the second-story window, that piano has high potential energy because it's suspended 2 stories above the sidewalk. How is it likely to change? Is it going to float up or fall down? What do pianos do? Do they float around? No, they tend to fall straight down, right? It's going to change in a way that lowers its potential energy. And we find that this energy change drives chemical reactions as well. So objects or systems with high potential energy tend to be unstable. Some chemical substances have high chemical energy, which is potential energy. We can think of TNT, trinitrotoluene. TNT explodes, right? That's what it does. It's explosive. And it tends to do that because the molecules lower their potential energy by doing that. So they undergo this rapid chemical change that lowers the potential energy. So we need to be able to think about energy with these chemical and physical changes. So we have exothermic reactions and endothermic reactions. And again, we've got prefixes. So exo is like exit, and endo is like in. So exit. Do you go out the exit or do you come in the exit? You go out the exit. Exit means to leave. So in an exothermic reaction, exo meaning out, going out, exit, thermic relating to thermal energy, exothermic, energy is released. The energy goes out. In an endothermic reaction, the energy is absorbed. It comes in. There are a lot of things in chemistry where we have these 2 pairs. We've got exo and endo. We've got energy being released and being absorbed. And we have to keep them straight. 50-50 is not a good guessing ratio on an exam. Okay, 50% will not pass you in this class. So we need to have some associations to help us keep these straight. We often diagram things in science to help us visualize these things that we can't see. So if we make a little diagram here, we have energy increasing. So something up here, like these reactants, has higher energy than something down here, which is the products. So what happens in an exothermic reaction is the reactants start with a higher energy and end up with a lower energy as the products. In this process, that energy, which is conserved, has to go somewhere. So something like butane burning or TNT exploding, energy is being released into the surroundings. This is the other type of reaction, an endothermic, where the reactants start at a low energy and they go to a higher energy. How do they get to a higher energy? They have to absorb energy from the surroundings. So in order for an endothermic reaction to occur, there has to be energy absorbed from something else. It doesn't just magically appear out of nowhere. We should be able to identify changes as exothermic or endothermic. So, wood burning in a fire, is that an exothermic change or an endothermic change? Exo. Oftentimes, we see or detect the energy as heat. We burn wood to heat up the house, right? Because it gives off heat. What about ice melting? How do you make ice melt? You would put heat into it, right? Putting heat in, the ice is absorbing energy. Ice melting is an endothermic change. How about water freezing into ice? If I put heat into the water, is it going to freeze? No. And yet you may say, yeah, but when ice freezes, it doesn't give off heat. Well, let's think about what your freezer does. There's a motor on your freezer and a compressor. And what it does is it's sucking heat energy out of the inside of your refrigerator and freezer. It's taking energy out. When water freezes, it does so because energy is being sucked out of it. Energy coming out is what kind of a reaction? Exothermic. So when water freezes into ice, it's actually an exothermic reaction. I live in Reedley, and we're surrounded by trees, fruit trees and vines. And in the winter, when we have a freeze, the citrus farmers are very concerned because they don't want their oranges to freeze. You can actually keep the orchard above freezing by watering, by flooding the fields with water. Because as the water freezes into ice, energy comes off and it moderates the temperature of the air. So chemistry saves oranges. Natural gas burning, exothermic or endothermic? Exothermic. So some of these questions are not obvious. You have to think about it. Where is the energy going? Is it going in? Is it going out? Sometimes, like with letter C here, it's easier to think of the opposite process. Water freezing into ice. It's not obvious to you that that's exothermic. But ice melting is the opposite, isn't it? Ice melting was more obvious. We have to put energy into it to make it melt. How about boiling water, changing from the liquid to the gas? Do we put energy into that or take it out? You put the pot on the stove and you light the burner and you put energy into it. So boiling water is endothermic. So then water condensing from vapor to liquid must be the opposite. It must be exothermic.